Let me ask you something. Have you ever thought that when you learn something might be just as important as what you learn? Well, today we're diving into the pretty wild world of order effects. We're going to see how this simple sequence of information can totally change what you remember, what you believe, and even the choices you make.
I mean, think about it for a second. You're trying to remember a grocery list, or maybe the key points from a meeting. Which ones really stick in your head? It's almost always the first few things and the very last one you heard, right? That is not a coincidence. It's a really powerful cognitive thing at work, and trust me, you experience it every single day.
So, this whole thing has a name: order effects. It's kind of the umbrella term for how sequence messes with our thinking. You've probably heard of the two most famous examples. There's the primacy effect. That's why first impressions are so powerful, because those first items get locked into our long-term memory. And then there's the recency effect, which is just that the last things we hear are still fresh and easy to grab. But as we're about to see, this goes so much deeper than just a couple of memory tricks. For the longest time, the scientific models that we use to understand learning had this massive blind spot. They kind of treated our minds like a big bucket you could just pour facts into, completely ignoring that the order of those facts could change literally everything. So the real challenge for researchers wasn't just observing the outcome, saying, oh, look, people remember the first item. The real goal was to understand the actual step-by-step process happening inside our heads. What's the mechanism that makes that first item so sticky? How does the sequence of events actually build our understanding of the world? Now, to crack this nut, scientists turn to something called the algorithmic level of analysis. I know, it sounds super technical, but the idea is actually pretty simple. It's all about mapping out the recipe, the specific steps and rules our mind follows to do something. It's the perfect tool for finally cracking the code of these trial order effects. And this chart really shows you the before and after. The traditional models, totally insensitive to order. They gave us this blurry general picture. But these new algorithmic models, they are built from the ground up to treat sequence as an absolutely critical part of the learning machine, showing us the hidden step-by-step process for the first time.
So, with this new way of thinking, how did it completely change our understanding of one of the most basic things our brain does? Sorting the world into different categories.
The old way of thinking about how we learn categories, like what makes a dog versus a cat, just assumed we see a million examples all at once and kind of average them out. But we all know from just living, that's not how it works. You learn one example, then another, and then another. And that sequence really matters. So to solve this problem, researchers came up with two really groundbreaking models that put sequence front and center. Each one has a really unique way of explaining how our brains deal with order. There's the locally Bayesian learning model, or LBL for short, and the ordinal general context model, also known as the OGCM. The LBL model is seriously clever. Instead of thinking of the brain as one big processor, it pictures it as having different specialist teams or modules. As we learn something, these modules pass messages to each other. So imagine a color expert module telling a shape expert module, hey, that first thing I saw was red. That little message influences how they both see the next object. It's this trial-by-trial conversation that just naturally creates these order effects. Now, the OGCM took a totally different route, but it's just as brilliant. It basically said, what if the brain treats the order something appears in as just another one of its features, like its color or its shape? So being first or third in line gets coded right alongside being red or round. And you know what? It worked. This quote from the research pretty much confirms that when the model started including serial order as a feature, it got way better at predicting how people would actually classify things. It wasn't just a cool theory. It made the model genuinely more accurate. Okay, so we've seen how order shapes learning, but it definitely doesn't stop there. Let's take a look at how this exact same principle directly sways our beliefs and the decisions we're making every single day. And the impact is, well, it's everywhere. It shows up in something called belief anchoring, where the first piece of evidence you get just holds on for dear life. It affects how you answer surveys, and it even influences how we make really complex judgments. The sequence of information is constantly giving our choices a little nudge. Let's just focus on belief anchoring for a minute, because it is such a powerful real-world example. This is the classic first impression bias. The very first piece of information you get about a topic or a person or a product, it acts like an anchor. And every piece of information you get after that is judged based on that anchor. And let me tell you, it is incredibly hard to pull that anchor up once it's been set. So, what's actually happening here? Well, our brain isn't just passively collecting facts and putting them in a filing cabinet. No, it's way more active than that. It's constantly keeping this internal reference point. And with each new piece of info, trial by trial, that reference point gets shifted. This explains why a really strong first piece of information can so powerfully move that reference point and influence every judgment that comes after it. So this leads us to the final piece of the puzzle. If our minds are following these step-by-step sequential processes, how on earth can scientists map them out when they're totally invisible? Yeah, basically, researchers needed a way to draw a flowchart of our thoughts. They needed tools that could somehow peer into the black box of the mind and figure out not just what processes are happening, but the exact order in which they happened. I mean, it seems impossible, right? You can't ask a person, okay, so did you process the sound of that word before or after you remembered what it means? The processes are just too fast, they're too subconscious. So, how do you solve that? Well, the answer is a really clever technique called tree inference. Think of it like this. Imagine you're trying to map a factory's assembly line, but you're not allowed to look inside. What you can do is intentionally jam one of the machines and then see what kind of messed up product comes out the other end. By methodically messing with different parts and just watching the result, you can work backward and map the entire hidden sequence. That is exactly what researchers do to map our invisible mental steps. So, after all this talk about algorithms and models and tree inference, let's zoom back out. Why does understanding the sequence of our thoughts actually matter in the real world? Oh, it matters a ton. Knowing about these effects helps us spot our own biases, like that belief anchoring we talked about. It lets educators design better ways to teach, where the sequence of topics actually helps students learn and remember more. It makes us more critical consumers of news and social media because we're aware that just the order of the headlines can shape our opinion. And really, it proves that how you encounter information can be just as important as the information itself. And all of this leaves us with a final, pretty provocative thought to chew on. If the simple order of events has such a deep impact on our memory, our choices, and our beliefs, how much of what you hold to be true right now is simply because of the accidental sequence in which you happened to learn it?